Very simple problem. So first of all I will make sure that in three-dimensional motion acceleration, instantaneous acceleration can be written as ax I cap plus ay j cap plus az k cap. So earlier I had written only for two-dimensional motion, that is ax ay, and if it is considered with the three-dimensional motion, then acceleration value becomes like this. Okay. Then coming back to numerical, what it says, position of the particle is given. Let us write the position of particle first. So vector r is equal to 3t I cap plus 2t square j cap plus 8k cap. This is the position of the particle in a three-dimensional view, because here we have I cap, j cap and k cap. That means position along x-axis it is like this. This is x-axis, this is y-axis and this is z-axis. Along x-axis we have a 3t value, and along y-axis you have 2t square, along z-axis you have 8. So this is the change in the position of a body with respect to its coordinates. So this is the change in position of a body, and where t is in seconds and coefficients have proper units. I cap, j cap and k cap have proper units and are to be taken in meters. They are asking what is the velocity of the body and what is the acceleration of the body when it is moving in a three-dimensional condition. So three-dimensional means body is moving in a space, or you can say it is changing its position x, y and z. Find the magnitude of that velocity and corresponding acceleration. Clear? At a time t equal to 1 second. At 1 second we have to calculate that velocity, instantaneous velocity at t equal to 1 second, and instantaneous acceleration at t equal to 1 second. Clear? Then coming to this, when you want to calculate, I told you always if you go from position to displacement, I mean of course this is the rate of change of position gives what? Velocity, and again that rate of change of velocity gives acceleration. So we can write this velocity as dr by dt, because if you differentiate this, we will get rate of change of position gives velocity only. So always remember, if you want to go for position to velocity, you have to differentiate with respect to time, dr by dt. This itself is what we call it is velocity. V is equal to dr by dt. Clear? Okay. Then I will be taking this differential form, like I will write 3t I cap plus 2t square j cap plus 8k. So here velocity is, 3 I cap I will take outside, and differential form of dt by dt plus 2 j cap I will take outside, and differentiation of this t square remains there, plus k cap is taken outside, differentiation of this constant term 8. I will write directly, 3 I cap, differentiation of dt by dt is 1 plus 2 j cap, differentiation of t square is 2t, I have explained how it is, plus differentiation of constant term is 0, differentiation of 8 is 0. Then we can write vector v is equal to 3 I cap plus 4t j cap, and this is 0. So this is our velocity of the body. That is vector v is equal to 3 I cap plus 4t j cap. So I want to calculate the acceleration. Differentiate again. Acceleration is equal to rate of change of velocity with respect to time gives acceleration. What is v value here? 3 I cap plus 4t j cap. Then again acceleration is equal to, you take 3 I cap, I will take I cap outside, then differentiation of 3 divided by dt plus 4j I will take outside, differentiation of t divided by dt. dt by dt gives 1, clear, and this is constant term. I told you differentiation of constant term is 0. Then here vector A is equal to this constant term differentiation value is 0, then plus differentiation of dt by dt is 1, that means you are getting 4 j cap. Your acceleration is 4 j cap. Got it? So we have calculated first one, velocity and acceleration. We'll find out its magnitude of velocity and as well as magnitude of acceleration at a time interval t equal to 1 second. Just I want to calculate magnitude of velocity. Clear? So to calculate the magnitude of velocity, what we will do? We will take components of ijk, sum of squares of component of ijk. That is v is equal to square root of, what is vx value here? This is velocity along x-axis. You can take this as 3 square plus what is velocity along y-axis? That is 4 t square. Then we can write v is equal to 3 3 is 9, 4 4 is 16 t square at time t equal to 1 second. That means if you substitute this, what you will get? V is equal to square root of 9 plus 16 1 square, that is v is equal to square root of 25. This is 5 meter per second. This is the velocity. Clear? Okay. Then go for acceleration, magnitude of acceleration. Before that, I will calculate direction of this velocity. Tan theta is equal to vertical component of velocity divided by horizontal component of velocity. Vertical component of velocity is 4t divided by horizontal component of velocity is 3. At time t equal to 1 second, you take, substitute here, tan theta is equal to 4 by 3, t is equal to 1, 4 by 3. That is theta is equal to tan inverse of 4 by 3. Tan inverse of 4 by 3 value is nearly it is equal to 53 degree with x-axis. With x-axis. Clear? Okay. Then I am moving towards acceleration. See, to calculate the magnitude of acceleration, if you get, of course we will take component of ax square plus ay square, then a is equal to component along x-axis. We don't have any change in velocity along x-axis. We don't have any acceleration along x-axis, and hence we will take only component along this one. So in this case, what will happen? You will get 16 again, then 16 is 4 meter per square second. If there is only one, no need to go for that. Directly you write the answer 4 meter per square second, right? To represent that, I have taken ax square plus ay square to show you. Again you will get 4 only. If there are two components, then it is definitely we can go for magnitude, and otherwise if there is only one component, that itself is the answer. So this is acceleration is equal to 4 meter per second square. Now let us go for direction of acceleration. How to calculate direction of acceleration? Direction of acceleration, you know the formula, that is tan theta is equal to vertical component of acceleration divided by horizontal component of acceleration. Then tan theta is equal to vertical component of acceleration is 4, horizontal component of acceleration is 0, that is 4 by 0 is infinity. Then theta is equal to tan inverse of infinity, so theta is equal to 90 degree. So tan 90 degree value is infinity. Got it? So this 90 degree with x-axis. With x-axis. Clear?